Hello students, hope you're doing good and welcome to another lesson. Today the topic is about location and direction. It is a very interesting topic, but not easy. That's why we're gonna start with a role play to put you in the mood of the topic. So the role play is about a student who goes back in time to discover how 2,000 years ago people used to locate places on Earth and go from one place to the other. So let's start with the first role play.
Oh, hello ancient Egyptians.
Well, hello there, young student from the future.
What are you guys doing?
Well, we are looking at the stars. They help us find our way back home.
Oh, that sounds so cool.
Yes, we have to do a small calculation.
But do you mind if I guys tag along with you?
Are you ready for a long journey?
Yes?
Okay.
Great. Oh, first, let's take a selfie.
Hey students, so like you saw in the role play, student Dylan went back 2,000 years ago to find out how people back then used to locate places. Now student Dylan is gonna go back to the 1950s, 1940s to see how people used to locate places in that time.
Hello, people from the 50s.
Oh, hello there, student from the future.
What are you guys looking at?
Well, we're trying to get to Washington, D.C. We're using the compass. It's telling us the north, and then we're using the map. The map has the longitude lines and latitude lines. They intersect, and they will give you the correct direction. For example, we're going to Washington, D.C., and it's 39 degrees north and 77 degrees west.
Okay, cool. That sounds super helpful.
It is.
Oh, by the way, love the music.
Hey students, I hope you enjoyed the role play about the longitude and latitude lines in the 1950s. Let's watch a video now to give you more information about the longitude and latitude lines. I would like you to pay attention to the information in the video, as this will help you with the quiz at the end of the lesson. Let's start the video.
Let's take a look at it and see how you can use it. Directions help us figure out where we are and where we're going. If you want to locate a certain place on a map, like Los Angeles or San Francisco, it's important to understand directions. The four main directions on a map are north, south, east, and west. These are known as cardinal points, or cardinal directions. If you're looking for cardinal directions on a map, you might look for the compass rose. A compass rose is a symbol that shows the main directions on a map. It is sometimes decorated with the compass points, the directions, looking like flower petals. But north, south, east, and west aren't the only directions. There are also intermediate directions, directions that fall between each of the cardinal directions. The four main intermediate directions are northeast, southeast, northwest, and southwest. Let's say that you are flying from Los Angeles to San Francisco. In what direction are you traveling? Not exactly north and not exactly west. You're traveling between the two, which is northwest. Northwest is pretty specific, but it only tells you where one place is in relation to another. You can be even more specific when locating a place on Earth. That's where lines of latitude and longitude come in. Lines of latitude are imaginary lines that run from east to west around Earth. Lines of longitude are imaginary lines that run from the North Pole to the South Pole. Lines of latitude and longitude form a grid, a pattern of lines, that helps us find the exact location of a place. Each line is measured in degrees. Degrees are numbers that tell us exactly where the lines are on Earth. Together, degrees of latitude and longitude indicate a place's absolute location, the exact location of a place on Earth using degrees north or south and east or west. The absolute location of a place is defined partly by its degree of latitude, north or south of the equator. The equator is the line of latitude that goes around the middle of Earth. This is how we measure points of latitude. For example, Los Angeles's latitude is about 34 degrees north. That is 34 degrees north of the equator. The absolute location also includes a place's degree of longitude, east or west of an imaginary line drawn from the North Pole to the South Pole that passes through Greenwich, a town near London, England. This line is called the prime meridian. The prime meridian is Earth's main line of longitude, and it's the line from which we measure degrees of longitude. So, for example, Los Angeles's longitude is about 118 degrees west. That is, 118 degrees west of the prime meridian. So, to determine the absolute location of Los Angeles, we put latitude and longitude together and come up with 34 degrees north, 118 degrees west. Now let's find the absolute location of San Francisco. We know that it's located in Northern California and that it's northwest of Los Angeles. But we need to find its latitude and longitude in order to determine its absolute location. Let's do latitude first. There's the equator, and there's San Francisco. It looks like San Francisco is about 38 degrees north of the equator. Next, we'll find its longitude. There's the prime meridian, and there's San Francisco. What's its longitude? If you said 122 degrees west of the prime meridian, you're right. Now, let's put San Francisco's latitude and longitude together. If its latitude is 38 degrees north of the equator, and its longitude is about 122 degrees west of the prime meridian, its absolute location is 38 degrees north, 122 degrees west. As you can see, maps and globes have all kinds of absolutely cool features that help us answer the important question: where are we? Cardinal directions, intermediate directions, lines of latitude, and lines of longitude. All of these help us figure out where we are and where everything else is too.
So students, let's do now a reading activity. We're going to read about longitude and latitude lines. For this, please pay attention to the pronunciation, also for the information in this paragraph, as this will help you with the quiz at the end of the session. So students, let's start reading about latitude lines. So lines of latitude, also called parallels. Circle Earth parallel to the equator. The equator is an imaginary line that lies halfway between the North Pole and the South Pole. So it is here in the middle. It runs east to west, all the way around Earth. Lines of latitude describe positions north and south of the equator. Lines of latitude are measured in degrees. Degrees may be broken down into smaller units called minutes and seconds. The equator is 0 degrees. The North Pole is 90 degrees. And the South Pole is 90 degrees south. Lines of latitude north of the equator are numbered 1 to 89 degrees. Lines of latitude south of the equator are numbered from 1 to 89 degrees south. So now let's read about lines of longitude. Lines of longitude run between the North Pole and the South Pole. These lines are also called meridians. Like lines of latitude, meridians are measured in degrees, minutes, and seconds. The north-south line that marks 0 degrees longitude passes through Greenwich, England. This is called the Greenwich or prime meridian. Why did we choose Greenwich? Greenwich was chosen for the prime meridian because when the system of latitude and longitude was established, Great Britain was a world leader in exploration and map making. Greenwich was the home of Britain's Royal Observatory. So students, let's have an example about the lines of longitude and latitude. Okay, for this, I've chosen the map of the United States of America, and we want to find together the coordinates of Washington, D.C., which is the capital of the United States. So for this, you see that when it comes to lines of latitude, Washington, D.C. is between 30 degrees north of the equator and 40 degrees north of the equator. It is nearly 39 degrees north of the equator. Now, for lines of longitude, okay, so it is between, here you can see 80 degrees west and 70 degrees west. So it is nearly at 77 degrees west. So the coordinates of Washington, D.C. are latitude lines, so it is at 39 degrees north, and longitude lines 77 degrees west. So students, let's watch now a role play on how nowadays we can locate a place on Earth. So not anymore, we don't look at the stars and we don't open a map and look at the longitude and latitude lines. But everybody has on his phone now the capability to find the location of any place on Earth. Let's watch this role play together. Hey Sean!
Hey George, how are you?
Come on, where's Dylan? We're
Dylan?
gonna be late for the party.
I don't know, I think he's lost.
Oh, come on, man, send him your location.
Okay.
Oh, man.
Good idea.
You gotta love technology, man. All right, now call him.
Yo, Deals!
Yo, yo, yo!
Alright, did you get the location? I just sent it to you.
Let me check. Yes!
Alright, come now.
Alright, see you soon.
Fantastic. Whoa, Dylan!
What's up?
How was your trip to the past?
Pretty awesome, man.
Fantastic, man. You'll tell us all about it later, but for now, we gotta go party.
Yeah!
So students, I hope you enjoyed this role play. So we were able to share our location because our mobile phone has a GPS. Let's watch a video to learn more about how a GPS works. please pay attention to the information in the video as this will help you with the quiz. Good luck!
We throw the acronym GPS around all the time, and sometimes we'll even refer to Google Maps or Apple Maps as GPS. But the truth is, they aren't GPS. They're just GPS receivers. So, is that a satellite in your pocket, or are you just happy to see me? It's a satellite in your pocket. GPS isn't just a feature on your iPhone or an inbuilt service in your car. It's actually the entire system of up to 30 satellites that were put into orbit by the US government to assist us in determining exactly where we are on Earth. GPS relies on the visibility of at least 4 satellites in the sky at all times from any position on Earth. The calculation of where exactly you are on Earth, as well as what altitude you're at, relies on the mathematical principle of trilateration, which is similar to the concept of triangulation, a process that allows you to determine the position of a point based on its relationship to the other points in space. You can calculate the distance between yourself and any satellite by comparing the time delay between a radio signal sent by the satellite and the receiver. Because we know radio waves travel at the speed of light, we can calculate the distance from the satellite based on time. Once we have known distances from a point on Earth to 3 or more satellites, we can find the exact point of intersection of all of the spheres of possible distances from all of the satellites. This position is our position on Earth. You might be surprised to learn that GPS, the Global Positioning System, has been around in one form or another since 1973. In the 1990s, the US military was frightened of the idea of adversaries using GPS for ill, so they made it a public resource and purposefully degraded the signal. So let's all thank the US government for keeping this system up to date and trusting us with only using GPS for good, like finding out how far exactly we are from the closest Chipotle. Ooh, Siri, I need a burrito. Hey, thanks for watching. Make sure to like this video and subscribe to this channel for more Mashable Explains. Also, don't get yourself lost. Make sure to leave a and leave a comment. Let us know what you think of the episodes and maybe what you would like us to explain next.
Students, now it's quiz time. I know the lesson was not easy. It's a little bit complicated. It has a lot of information, but I know that you can do well in the quiz. So, susu and good luck.
Education is the most powerful weapon which you can use to change the world. Have fun!